project I'm kicking off today's presentation on is a water leak detection project, which is a collaboration between FarmBot, based in Sydney, and CSU and Food Agility, and looking at what are the opportunities using the FarmBot technology to automate some of the farm water system monitoring and reporting requirements around the farm. We're all fairly aware that there's a lot of water in the landscape as it is at the moment, but even in that scenario, that the actual watering systems are actually a critical animal welfare system across any of the properties where we've got livestock grazing or in feedlots, however it's working. And that in many instances, the water is actually a limited resource. We don't have it to spare, and so we need to be monitoring quite closely how much water we've got in the system, whether it's making its way to where it needs to be across the farm for animals to be able to access it. And that historically, it's been a relatively time-consuming and expensive exercise for producers to be monitoring their systems around the farm, and it has been traditionally a manual process. And in some of the larger enterprises, you can actually have staff who are entirely dedicated to spending their week Monday to Friday driving around from one paddock to the next, looking at troughs, looking at tanks, looking at dams to try and make sure that there is in fact water available and flowing for the animals to be able to access. And so it really is just it's a critical resource. Producers need to know where it is that their animals are able to access it. FarmBot is an Australian company based in Sydney that have a number of tech solutions that's been marketing for a number of years to actually help solve these problems and look at how we can be using sensors and communication systems to be able to monitor what's going on with our watering supplies. So it's a relatively straightforward process today to order a system, a tank monitoring system, where essentially it drops a pressure sensor into a dam, mounts a communications unit on the top of the dam, and it can be continuously monitoring 24 hours a day what the level of the water in the particular dam is. And that in order to access that information, there's a fairly straightforward dashboard that the producer logs into, the graph here on the right, and you can see from one day to the next exactly what the water level is in the tank. And then ultimately you might, in this instance, on top of the tank as well is an electronic rain gauge. So you can be looking at exactly how different amounts of rainfall are contributing to the tank status. And then as the animals are using the water or other uses for the water, the tank levels drop again, and you've got full visibility of what that looks like. So that can be a really handy system to have. It doesn't necessarily report if there's a catastrophic failure somewhere else in the system, but it can tell you if over time that water levels are dropping when you're not expecting them to, or if the water levels are dropping at a rate that you're not expecting them to. Further down the system, it's also possible to put a sensor just directly onto individual troughs. And so certainly in some of those extensive operations where it can be tens of kilometres between troughs, the monitoring of them can be really a lengthy process. So to be able to put a sensor such as this one onto an individual trough, and then you've again got that 24/7 visibility of is there water in the trough? Are the levels going up and down as expected? You can see when as water use is occurring, you can be monitoring that as you go. These particular systems, the current version of them is generally a wireless system. So the particular unit is mounted on the trough, and it's broadcasting its data to the communications unit, which then can be mounted somewhere away from the trough where it's less likely to be interfered with by the livestock. The particular configuration we've got here at CSU, I think it's about 150 metres from the trough across to the communications unit, which is sitting on top of a dam, on top of a tank in this particular instance. And so having a network of those across the farm, again, can be telling you what's happening in the trough. One of the issues with trying to identify when there are leaks in the system, in a system like we have here at the university, where it's a pressurized system, we can actually have a leak in the system. So there's water can be spraying out of the pipeline somewhere along the way, but all the tanks are still being filled, all the troughs are still being filled. It doesn't actually tell us when we've got a leak in the system. And so I think largely that was the basis for this particular project, was to look at, well, how can we, with additional sensors and instrumentation, how can we detect when there's a leak somewhere in the system? And ideally, can we locate where in the system that is occurring? Because it's potentially a farm may have tens of kilometres of pipelines scattered across the landscape. And when you identify that there is a leak, then you want to be able to track down where it is as quickly as possible. And because surprisingly, it's not always that obvious where that occurs, and we'll get to an example of that in a little while. So the project that we've kicked off, started the beginning of this year, was looking at instrumenting one section of the Global Digital Farm here at CSU, which is in itself is a food agility supported program, where we're looking to completely saturate the mixed farming operation that we've got here in Wagga. So it's a 2,000 hectare farm producing 1,000 hectares of crop, and we've got 500 Angus cattle and a couple of thousand ewes. So it's quite a diverse operation. But on one of those particular farms, which is a perennial pasture-based system where the 500 Angus typically reside, is that we've instrumented the entire farm. So every trough on the farm now has a pressure sensor and a flow rate meter in the line that goes to each of the troughs. So that way, conceptually, we can actually be monitoring what's happening within each trough in real time. And that by monitoring all the stock numbers within the individual paddocks, the idea is that ultimately over time, we can actually get to the point where we can characterize what is typical water use for individual animals, different ages at different times of the year. That clearly you would expect that the water use of a pregnant cow in February might be quite different to the water use of a calf in July. And so ideally we'll be able to identify those sorts of things as we're going through the project. But then ultimately, if we can identify those typical water use patterns across the day and for different livestock, then ideally we should be able to identify using some algorithms and analysis of the data when there is actually a leak occurring and where in the system that's occurring. And as Dave mentioned earlier, is that potentially with this information, we'd also like to think that there may well be some animal health metrics that might come out of the water use characteristics that we're going to be potentially identifying. When we think about the actual technology that needs to be put in place, the unit we've got here is the actual flow meter, is the blue cast unit, is the flow sensor, and the little unit on the left-hand side with the black cable running into it is the pressure sensor. So essentially what we needed to do is that at each line running to individual troughs where we wanted to be measuring and monitoring the system, we needed to insert one of these units, which didn't sound like it was going to be too much of a drama until you physically do have to start getting out into the paddock and locating lines where over time, the local knowledge of where those lines are can actually start to become a bit of a challenge. But ultimately we managed to get there in the end. So this is the data side of the system. So it's what's actually doing the measuring. The cables that come from those sensors then connect to somewhere within 5 to 10 meters a communications unit. So this is the standard FarmBot monitoring system. Got a solar panel, internal batteries, and then either satellite or cellular communications systems integrated into it. And these particular units are sort of generic across the whole range of sensors that FarmBot are offering. So in addition to watering systems, they also do fuel tanks, and there's some dam monitoring and liquid fertilizers, a whole range of different sensors. Well, they all connect up to these particular communications units, and they can be either wired or wireless, and you can be connecting up multiple sensors to an individual communications unit. So certainly we've got instances here on the farm where we've got rain gauges, trough sensors, other sensors all connected into a single unit, which is then broadcasting at regular intervals the data back to the cloud and to the dashboard. When it came to, just going back a couple of slides, so we can actually see here on the map that each of the red dots is identifying where there is a flow sensor and a pressure sensor being installed, and then the yellow dots or the yellow pins are where the communications units are. So there are some duplication in the system. So we don't need to have as many monitoring systems as we do with the actual communications units. This season, when it came to actually installing the units, we did have some issues with just farm access and wet conditions, and it ended up being a little bit more of a drawn out process than we were originally expecting to get everything installed. And we certainly did have a number of instances where we're simply finding the buried pipeline was a bit of a challenge, and where we had farm staff who were absolutely certain that a line was within a metre either way of where they were standing, and the team, Nelson and Jackie and others helping out, have ended up digging tens of metres of trenching and still not been able to find the pipeline. And in the worst case scenario, we're sort of resorting to just using a trencher and basically heading across the countryside and waiting till we find the leak, which in a fairly high pressurized system becomes fairly quickly apparent when you do hit the pipe. But then we can get on with doing the install when that happens. Ultimately, once the process is up and running, so you see here on the left-hand side, we've got the flow meter and the pressure sensor inserted into the flow line. Once that's installed like that, we're then able to put a typical underground communications inspection box over the top of that, which you can see is the hole in the ground in the middle. The middle photo, and then run all the cabling underground and up through the center of the pole that the communications unit is then attached to. So you can see, that's ultimately what the system looks like, and there's one of those at each of the troughs as we drive around the farm. What the data then starts to look like once everything is connected is that we're essentially able to then start looking at the pressure data and the flow data instantaneously as it's being recorded. On for the graphs that we've got here, sort of going left to right, we've got the instantaneous line pressure for 3 separate paddocks, sort of top, bottom, and center over a 36-hour period, and then the corresponding 36-hour period where we're just looking at the volume of water that was flowing through the line at that same time. So we can see here that at around midday each day, there was a peak in the water use, so the volume of water that was being used, and that corresponded to a drop in the pressure in the system. And so it fairly robustly was telling us when there was water flowing into the troughs, which was indicating that the animals were drinking, and that there are actually quite large parts of the day when the animals aren't drinking. What we don't see here is whether there was rainfall, the climatic conditions, all those sorts of other things that are actually contributing to water use. And so that's part of the extra data that we're capturing as we're going. And this is essentially the sort of baseline data that ultimately we want to be able to characterize with the system. One of the things that we actually noticed as we were doing the install process, and we hadn't actually started really monitoring the data, was that at one stage there was a dramatic drop in the pressure of the system. And so it dropped from being approximately 1,000 kPa to about 500 kPa across the system, which indicated to us that, well, we thought there was going to be a leak, and that the installation process had been a bit of an educational process, that because of the pressure that we do have, is that some of the connections, it did take a long time to get them properly sealed. And so we were assuming that it was a leak associated with something that we'd done. And we spent quite a few days trying to ground truth the system to find where in our installation process we'd caused the leak. But we weren't actually able to find that. And so we then had to start looking around the rest of the system, and we couldn't sort of detect where the leak was. But then ultimately the farm manager was able to detect in amongst an area of timber that there was actually a leak in the system, had repaired it, and it returned the pressure back to normal. What was interesting to note was that across that whole period, it didn't actually impact on the water use or the water availability to the troughs at all, that there was still quite a lot of water flowing, that the animals didn't suffer. But this is one of those instances where just looking at the water in the troughs isn't necessarily isn't the full picture, that we do need to be looking more deeply at the system to be able to characterize what's going on. And essentially that's the nature of the project that we're going into. So the actual data, as it's starting to flow, is essentially just a CSV that we're able to download, where every half hour or so the system reports what the cumulative flow of water, or the volume of water that's occurred for each of the different sensors. But then also with the pressure, it actually has its own schedule for when it updates the data, and it's based on an event-based system. So whenever there's a change in the pressure, it then sends the data through. So it's less of a regular reporting period. It's more intermittent. In addition to the sensor data, we obviously need to know how many animals are in each paddock and when they're being moved around, so that we can be tracking what the water use might be and what particular class of stock there is. We need to know about how much rainfall there is, what the temperature is. So again, to be able to looking at that characterization process, and even what the pasture condition was, to see in your early spring wet conditions, it might be that a lot of the moisture or the water that the animals require is actually coming directly from the pasture, rather than needing to be accessing it from the troughs themselves. As the system's up and running, then ultimately to characterize the data, it's a case of essentially just monitoring the system and seeing what water use, what water pressure changes we can tie to different animal populations, different animal classes. But then separate to that, we also want to be able to look at how precisely and accurately can we identify leakages in the system. And so looking there at undertaking some controlled events, where we'll basically have our own tap in the system, where we can turn on a tap with flow meter attached to it, and we can intentionally have a water flowing out of the system at 10 litres a minute, 50 litres a minute, whatever the particular amount is, and then see how the system responds to that, and then what an algorithm might look like to be able to identify that sort of thing. So it's very much the work that we're in the process of commencing at the moment. We're now out to about 4 months of data, I think it is, starting to flow through the system. So we're sort of ready to be getting the data science team involved. But then over the next few months, as that all starts to come through, the FarmBot team are looking to be able to ultimately update their dashboard, so that the information being reported by the system just on a day-to-day basis can be improved. But ultimately, we really would like to be able to have an alert system where if there's an identified leakage of above a particular volume, then it might be that there's a text message or an email that gets sent out to the manager of the system, as well as being reported on the dashboard. That ultimately that there are some different metrics that the system could be reporting as part of the generic dashboarding system, and then ultimately we can be continuing to verify that the sheep and cattle are happily being monitored and they're being watered. And that really, I suppose, the animal health metric is the one thing that's most uncertain at the moment, as to whether or not we're going to have enough data, enough detail in the data, enough length of time in this initial period to be able to come up with any animal health metrics, or whether that's something that might take 2 years, 3 years, 5 years worth of data before we can start to identify where that's up to. And certainly the catchphrase that the FarmBot team like to refer back to in this whole system is that traditionally, we like to think the system is working. Driving around, we're not seeing any particular issues in the water system, but a system like this potentially really can give peace of mind that you can at any time of the night or day log into a dashboard and actually tells you that yes, the system's up and running, it's doing what it's meant to, and that you can go about your daily activities. And so, Dave, there's my 20-minute overview of where the project's up to. Do you want to throw to some questions?
Look, thanks, Joe, and thanks to the broader team, including FarmBot. I know FarmBot really had to pull their finger out and do some heavy lifting in the early days when it was really hard to get hardware. So greatly appreciate that. You comment about the nature of the data and, and trying to push it for livestock, for example. So I know you're on a pressure run system. So you're talking about, 9-10 atmospheres of pressure in the pipe. I think you said it had 1,000 kilopascals there on your graphs. What's your sense about the applicability of this approach to, say, a gravity-fed system where you'll have nothing like the head pressure, but at the same time, you may get more signal out of the noise in relation to these unwanted flows. Have you got a bit of a sense, just thinking a little bit ahead, beyond your project, I guess, as to how applicable this could be for gravity-fed systems?
My understanding is that the sensitivity in the sensors is such that really shouldn't matter, and so that was part of the FarmBot offering. Is you do need to identify what is the magnitude of the pressure in your system, and so then the pressure sensors are sort of tailored to meet that. It's certainly that expectation that towards the end of the project to be able to, if we get to the point where we can generate some alerts and FarmBot look to integrate that into the system, is to then reach out to some additional producers to be testing that, and to go to systems that have different gravity systems or just lower pressure pump systems would be the obvious use cases to be able to do that. And so to some extent we are working in that best case scenario where we do just have such dramatic or high pressure, but there are plenty of in this region. Most farms are connected up to a regional water supply, so it's going to be applicable for all the farms in this region. We then need to reach out to see how we make it work with other systems.
Yeah, nice. And noting this project's really only just getting started now, and a big shout out to Nelson West, who's done a lot of heavy lifting down the paddock with the crowbar and the shovels and whatever. And I haven't seen any posts from him in Bogged in the Crop 2022 on Facebook. If you're interested, go to check out Bogged in the Crop 2022. It's a great Facebook site for mud related experiences. But Jono, now that the data's flowing, are you confident, when you look at the nature of the data, the quality, the resolution, both temporal and also pressure and or flow, you still feel pretty good about the outlook for the project in terms of how you want to drive the data?
Yeah, certainly, Dave. That's certainly just the gross water flow rates by themselves look like they're going to be really quite instructional. That there's some pretty distinct patterns in the data about, one of those questions I had when we first started off was, do cattle drink water at 2 and 3 o'clock in the morning? And from what we're seeing in the data, for the most part, no. And so to be able to identify relatively large leaks in the system, I think that really is going to be a relatively straightforward application, because typically there is such low water use at different times of the day that if suddenly we start identifying that even if it's only 50 litres or 100 litres an hour that is flowing, if suddenly the baseline between midnight and 6 o'clock in the morning goes from being nothing to 50 to 100 litres, then there's clearly a leak in the system. Or 1,000 litres, but I think the challenge will be that if it's only 4 or 5 litres in the system, whether or not we can pick up that kind of sensitivity. Until we really start diving into the data, we just don't know at the moment.